Good afternoon, everybody. My name's Andrew Scott. I'm with Tektronix, and with me here is Billy Romero from FuboTV, and we're going to talk to you about quality checks, monitoring for streaming video. So I'll talk a little bit first, talk about why we need monitoring, what are some of the types of errors that we can catch at various points in the workflow. I'll talk about some of the different workflow flavors, and then at the end, Billy's got some real-life examples of some of the things that they've encountered at FuboTV. So first, I'll talk about why should we do monitoring and quality control, and I'll start with a list of actual customer stories. So won't go into gory detail on each of these, but maybe highlight a few. I think a lot of this boils down to the tools or the processes for detecting issues start off being pretty basic, pretty rudimentary, and don't get a chance to dig a little bit deeper. So one example here is where on a program the left channel of audio was out for several hours. Right? We only had instead of the full stereo, we only had the right channel. And part of the reason there was because the monitoring was essentially looking at the stream on a laptop. And you can't tell if you've only got one of the channels available from a little laptop speaker. And so they just didn't even know until customers were calling in about that. What's another good example here? Problems with profiles. So of course in an ABR implementation, we've got multiple representations, multiple profiles available. If any of those profiles are missing, that could cause a problem for some particular viewers who happen to be, trying to retrieve that profile. Again, if the monitoring procedure in place is simply looking at the output of a Roku box on a TV, and that particular profile is never hit, you're not going to know. Right? The only way to truly find that is by monitoring all of the profiles simultaneously. So, there's lots of examples like this of cases where, simple viewing methods aren't enough to really uncover what's going on. So, to sort of elaborate on that point, I would say that, the starting point tends to be just looking at basic measurements, basic statistics from equipment in the workflow. So what is your encoder telling you? What's the packager telling you? Looking at some of the delivery stats, perhaps from the, our CDN provider and so on. We might be using simple tools like, again, a Roku box connected to a TV or, streaming it on a laptop or something like that. We're not going to get a lot of great visibility with those kinds of tools. And similarly, the expertise behind that, the team that's of engineers, operators that are taking a look at those measurement devices, if you will. Again, they're starting from usually starting from a small team and growing from there. A lot of streaming providers, they're relatively new startups. They're not like the incumbent large cable operators. So a small team to start with, and again, they may not have the ability to look in detail at what's going on. So that's with respect to the, from the operator's perspective. What about the monitoring tool? And what I'm describing here, what I feel some of the key elements or key attributes of a monitoring product, a monitoring tool. So again, I won't read from the slides. These are available for you to download as well, but I'll highlight some of the key points here. First, I'll talk about the difference between QoS and QoE. So I think it's important to look at both. QoS, quality of service, is essentially how well is my content being delivered. So it's about the delivery, as opposed to QoE, quality of experience, I think is more about the content. Right? So we can have viewer issues due to QoS, and that will be, there's download errors from the fragments, things like that. Whereas a QoE issue might be resulting from, encoding at a too low a bit rate, right? So you've got a high amount of compression artifacts. You don't have a good quality of experience for the viewer, even though the delivery is fine, the encoding is fine. It's just set up to not provide as clean a picture as perhaps we could have delivered to them. Another example from here, talking about API control. This is actually something that Billy's going to touch on later, what they've implemented at FuBu. So a key element of monitoring is the ability to scale alongside with what the services that you're delivering. So if you've got 100 channels, 100 live streaming channels, each of those is many representations in the ABR bitrate ladder. We need our monitoring tool to be able to look at all of that simultaneously, aggregate that up, and bring it back to a usable dashboard. And a key part of that is an API where you can pull the necessary metrics that you want and basically play with the data and make it available in a way that's more meaningful for your operators. So again, I don't want to steal Billy's thunder here, but he's got a great example of where they need to bring some of the stats from the monitoring tool and correlate those with other pieces of equipment. And the way of doing that is a unified dashboard where you've got talking to the API of multiple devices. It's another good example. So talking about thresholds and alerts. It's possible for a monitoring system to produce too much data, right? If I'm talking about that scale of hundreds of channels and many representations on each channel, that's the possibility of generating a tremendous amount of data. So it's useful sometimes to be able to go back and look at a moment in time. And if we had viewer complaints that from a program that was airing from 8 o'clock to 9 o'clock, we had some issues. You can go back and pull that data out of the database and take a look at what was happening at that time. So it's useful to save all that data, but you don't necessarily want to bombard an operator with a lot of issues. And that's where a good threshold and alerting system comes into play. The ability to set, at what point do I actually want to send a notification to someone, whether it's an email or a Slack message or something like that. Okay, so like I say, I won't talk about all of them. You've got the slides available. Next, I want to talk a little bit about the actual monitoring points and where can we look at things in the network. And I've got a few different stylized workflows, if you will, where I've highlighted a few points. So here's a possible streaming video provider's workflow. On the left, we've got ingest, and that could be either live or file-based content. So we could be ingesting a file that's put into a VOD library that can be streamed, or it could be a live channel that we're receiving. At that point, it's probably an IP stream. And all the way on the right-hand side are our screens, our viewer streaming devices. So in the middle, we've got several different functions, and there's a possibility of doing QC checks or monitoring points at each of those. So starting from the left, if we take a look at pre and post encode, there's a couple things we can do. In blue, I've got shown an IP monitor. So this would be more related to a live stream. So we've got a live input, it's maybe a broadcast network channel that we're streaming. And our IP monitor is taking a look and seeing if there's any issues with that stream in real time. So do I have loudness issues? Do I have any dropouts? Are my captions present? Things like that. So any of the compliance checks that we want to operate and video and audio quality checks. If it's file-based QC, again, now we've got sort of an offline opportunity for doing those same kinds of checks. Right? So if this is a file that we've ingested to be put into our VOD library, we can check it immediately as it's received and take a look, see if it's okay. We can check post encode, maybe even post package to make sure that the file package is correct and expected. In a few moments, I'll talk about some of the specific kinds of checks that we'd want to perform on file-based content. And then moving towards the right-hand side, this is now, post-packager. Now we've got our ABR package, right? So we've got our manifest, multiple representations of video and audio. And at that point, we can do some of the same kind of monitoring measurements as our IP monitor, but now it'll be based on an ABR package. So we'll point the monitor to a set of HTTP URLs, and the monitor can follow those URLs and read the manifest, look to see if there's any manifest errors, look at each of the representations, download each of them, and take a look and see if there's errors with the fragments, and even do a decode of those fragments and see if there's issues inside. So at one level, I would say our ABR monitor and our IP monitor are similar in that once you get to the video and audio, you're making similar measurements. Above that, though, the delivery is quite different. Right? Our IP monitor, we're looking at transport streams over an RTP network. Our ABR monitor, as I say, it's probably an HLS or a dash or a smooth streaming package that we're looking at. And our delivery metrics are going to be based on the ABR package. All right, so I'll back up in time a little bit here, and I'll spend very little time on this slide. I'll kind of move forward. But with respect to a traditional cable operator, that's those IP monitoring tools and our file-based QC tools were part of that workflow. Now, why I'm introducing this, at a streaming media conference, is to sort of show the transition that the traditional cable operators are undergoing right now. We've got some that are sort of running a parallel workflow. So in addition to the traditional cable workflow, we've got a parallel streaming workflow, and again, the same sort of monitoring points. But here's where it gets interesting. We've got some of the cable operators, they're sort of re-architecting for their next generation architecture. And instead of having parallel workflows or being sort of linear centric, now it's more streaming centric. And really what we're doing to fulfill delivery to our existing customers who have set-top boxes, traditional cable set-top boxes, is we can convert sort of back from a stream to linear at some point in the workflow. But the main part of our workflow is streaming centric at this point. These types of operators typically have their own data centers. They might utilize some of the public cloud providers later in the workflow, but a lot of this is still in-house in a private cloud. Okay, so with that context in mind of the different types of workflows, let's talk about the types of errors, so the kinds of things that can go wrong. First, I'll start with going back to on previous diagrams, I showed file-based QC tools. So let's start there. This would be sort of our earliest QC check in the workflow, applicable for VOD assets. What we want to do is basically look at those files as they're ingested or maybe post-transcode for several different issues. The most fundamental of which is my file intact? Do I have any truncation errors in that file? Any corruption? Depending on where we're getting who our content providers are, who's supplying these VOD assets, we might have a delivery specification in place. So, a house format that we're expecting, we can check for compliance against that. So is the format correct? And even internal to that package, is the metadata consistent with what we're expecting? So in terms of bit rates, codecs, frame types, things like that. Regulatory compliance is kind of an interesting thing that we can check, again, early in the workflow. Much better to return a VOD asset to our content provider if there are issues here than wait for it to, before it goes to air. So what I mean by regulatory compliance, things like audio loudness or caption presence, right? So we can measure if the loudness falls within the COM Act compliance, minus 22 to minus 26 LKFS for the loudness. Are the captions present? Do we have 608, 708 captions present or not? It's sort of mandated, so as I say, best to check that as early as possible in the workflow. And then the last item I've listed here is specific to a streaming workflow. If we're testing our package, our file, our VOD content pre-encode, pre-packager, one of the things that we can check for is that it's sort of ready to be packaged. It's ABR ready. And a good example of that is the use of EBP markers. EBP is an encoder boundary point. It's basically a signal to the packager that this is a place where I can have fragment boundaries, right? And an EBP point, there's Cable Lab specs in place that say what the minimum and maximum distance between them can be. One of the things we want to check for is the frame that EBP marker is associated with should be an IDR frame. IDR stands for instantaneous decoder refresh. It's basically an I-frame, if you're familiar with I-frames, P-frames, and B-frames. It's an I-frame where nothing after it references a frame before it. So it's the point at which we want our fragmentation to happen, because if we happen to transition from one profile to another in our ABR ladder at that fragment boundary, we don't want to be referring to video frames from another representation. That would be a kind of an ugly glitch, is how that would appear from the viewer's perspective. So these kinds of checks can be done on the file package before encoding, before fragmentation, to make sure that we've got a nice clean ABR package created. Okay, so moving on from the file-based, let's talk about streaming issues. And I've got more detail on each of this, but I've basically grouped them into these 5 categories of checks. And they sort of go progressively deeper into the package, if you will. So I'll just move ahead. So the first category I've got listed is channel availability. So, it's at a high level, it's a measure of downtime. What I mean by channel availability is, do I have, sort of a constant flow of fragments happening, or am I experiencing HTTP download errors, right? If part of my, if my manifest is pointing to a fragment that doesn't exist, that's going to be bad. That'll result in a stuck or a frozen frame from the viewer's experience, maybe even an incorrect frame if we've got a redirect happening. Some of the other measures we can make here are with respect to latency. So we can take a look at how long does it take to download an individual fragment versus that fragment duration. Do we have enough time to receive it and render it properly, or is buffering happening? And so basically you have the concept of like fragment overhead, the load overhead. If it takes me on average 5.5 seconds to download my fragments that are 6 seconds long, that's not so good, right? We're getting really, really close to the point at which the end viewer is going to experience some buffering every now and then, because of network conditions. So, that's a measure we can make to see if there's sufficient headroom for those fragments to be downloaded without error or without latency. And then lastly, an example here, and again, this is another one that Billy's going to touch upon, is a stale manifest. So this is, I would say, most important with live content, linear content versus VOD assets, because with VOD, the manifest basically stays the same, right? It's, one manifest is created for that 2-hour movie or 1-hour TV show, whatever. Whereas with live content, linear content, the manifest is constantly being rewritten, right? We're adding new fragments to the end and perhaps pulling fragments off of the top of it. And so that constantly evolving manifest, if it ever goes stale, right, if it's not updating, that means the viewer can basically hit the end of it, and again, they're stuck with a frozen screen with nothing to display. And again, that channel is unavailable at that point. So moving a little bit deeper, so we talked about some of the delivery issues. So let's talk about packaging quality. So again, it's kind of related. Some of the things that we can we want to take a look at here are all of the representations available in the manifest. Is the metadata for the attributes for each representation correctly displayed or correctly present in that manifest file? Is the MIME type correct? Things like that. In the manifest will be listed what the segment bandwidth is supposed to be, and so again, we want to measure is the actual bandwidth aligning with what we've signaled each representation's bandwidth supposed to be. The last point here, I guess I've got on DRM license and decryption key validity. So that's a big part of packaging. If we're if we're using a DRM system where the key is invalid, or we've got an incorrect configuration there, or if the DRM server goes away for a while, that's going to be an issue. One of the points that I had on one of my first slides was about a situation where the DRM server kind of went down for a period of time, and the operator didn't discover that because they just had an always-on, a monitoring screen, the Roku box or whatever. That particular playback session already had the key and can keep going, so it never saw that downtime from the key server. It's only for new people who are sort of starting the, wanting to look at that stream, weren't able to get in. So, to test this, basically you've got to continually be starting new streams, not just looking at the same one indefinitely. So now that we've gone from, the HTTP delivery and then the manifest, my M3U8 or, MPD for Dash, looking at that part of the package. Now let's go a little bit deeper and take a look at the essence, the audio and video tracks. So, whether these are MP4 or transport stream packets, there's, again, things we can do here. So we can do a decode on each of those fragments. Here we're looking for encoding compliance, right? Do I have any syntax issues? If there's, packet errors in the network, that might be reflected here as, a slice error, a missing slice in an MPEG transport stream. And that'll have an effect on what the, what the playback looks like. Our syntax checker here, we can take a look at buffer underrun and overrun. So basically running a buffer model that keeps track of transport stream segments as they're played back and the individual frames within, and keep track of whether we've overrun or underrun on our buffer. So those kinds of measurements we call syntax errors. They tend to get rolled up into a quality of experience type score because a syntax issue can ultimately it's going to reflect itself on how the image is rendered, and there's going to be issues there. So we call that QoE. Again, some of the other AV type issues, we've got mismatched format. So again, that could be maybe considered a packager issue as well if our manifest doesn't say what the right, what we're expecting versus what we actually decode. Captions can be decoded for syntax compliance as well. We can take a look and see if there's issues where we're drawing off of the side of the screen, right? So invalid sequence of caption commands and the text itself. One issue that can sometimes happen with captions is if the time code on that caption file sort of doesn't match what the expected where it gets inserted, when we're creating our package, you can end up with a stream where there is a 608 or 708 caption tracks with no text, right? And it's because it's expecting the text at a different time code location from where the file actually, where the file begins. I've seen that particular error with content that originated in the UK versus here, with VOD assets specifically. So in the US, it's very common to have the 1 hour mark is the time code at the beginning of our program. So you might have a header at the beginning that starts at the 59-minute and 30-second mark with black, and then at the 1 hour, that's the beginning of my program. They do a similar kind of thing in the UK, but they use the 10-hour mark. So if you get a package coming from the BBC and don't change the time code on your caption track, it's going to wait for the 10-hour mark, which never comes. And so you end up with empty caption stream. And then sort of the deepest check, if you will, on my audio and video. This is where we're actually potentially even going down to the pixel layer. So we're looking at not just sort of a high-level decode of my video and audio, but we're looking at the actual content itself. So some of these are relatively easy. Frozen frames of video. For audio, do I have dropouts? Do I have silence? We're actually looking at the decoded sample data to be able to make those kinds of measurements. Audio loudness, right? If we're looking at the sample data, we can look at the multiple channels and basically make that computation of the single loudness measurement spanning the multiple channels. From a video perspective, frozen frames, sort of an easy thing to check for. There's a couple of different quality metrics that we can apply to the video as well. And I've actually got another talk tomorrow. I'll just do a plug now at 10:30 in the morning. Well, I'll talk a little bit deeper on sort of the mean opinion score type of picture quality measurement. But what we're doing there is actually taking a look at each image and decoding it to the pixel layer, and it's actually a bit of a machine learning algorithm to try to correlate the pixel-based measurements on that frame with images that have been taught to the engine previously. And out of that, we have a MOS, a mean opinion score is what that stands for. But basically, it's like a number on a range between 1 and 5 that emulates what a human audience, how they would score that picture quality. Before that, we've got compression scoring. So again, an algorithm that's taking a look at the compression parameters in the bit stream and saying, well, this is a pretty low bit rate. I've got high quantization. This is probably going to be a lower score. My human quality of experience of that is going to be lower because it's going to look excessively blocky. So these are metrics that are computed from the video itself. So we've decoded all the way down through the manifest, the fragments, and so on, and looking at the video and audio to make these kind of measurements. And then the last category of errors that I talked about are very specific to digital ad insertion. So there's several things that we can do from a verification perspective here. Obviously, this is pretty key for a lot of operators because this is how they make their money, right? This is how they're monetizing their service. So if they're selling ad space, right, to clients, we need a way of verifying that that's actually happened and can generate a compliance report that lists that. So if we sell so many minutes or so many ad avails, we want to be able to measure that and say, yeah, we had 12 minutes of ad time during this hour and so on. And here are the ads that actually got played. So what this comes down to is taking a look at where the ad in and out points are signaled in the manifest. A lot of times with a streaming video service, what we're doing is manipulating the manifest directly for ad insertion. And I think there's a lot of potential with that technology over time to customize it for individual viewers and so on. We talked about whether it's server-side or client-side ad insertion. Ultimately, it's we're manipulating the manifest, and so our streaming monitor, is looking at that manifest, can basically follow what it's being told and take a look and see if those ads are present as expected. So because of that manifest manipulation, that's sort of an opportunity for different errors to happen at that point, right? We can have you know, a mismatch between formats, between our program content and our ad content. You know, we can have a different encryption format taking place, so that, you know, different things that we can check here. Again, the sort of the key here is to be able to you know, provide a meaningful report to prove that we fulfilled what that ad contract with, you know, was initially made with our providers. Okay, so I've covered each of the types of errors, and how are we doing for time? I think we're good. Yep.
Yeah.
Okay, so I'll hand over to Billy, and he'll talk about some of the specific cases at FuBu, and hopefully.
Great, thank you. All right. So I'm Billy Romero. I'm the video operations manager at FuboTV. If you don't know, FuBu is a virtual MVPD. We have about 800 live linear streams today. It's one of those things that's just constantly growing. Got a lot of like local affiliates, like NBCs and Foxes and things like that, as well as like, you know, national general entertainment content. So with those, you know, 800 streams, you know, some of those we actually utilize third parties to do some of the content acquisition, as well as the encoding and packaging. So they'll acquire it, encode it, and wrap it in HLS for us, then ship it up to our origin servers in the cloud, which is great. It's very convenient, but also you lose visibility upstream. So you're not, you know, you don't know anything about network issues, source issues, provider problems, things like that. So for us, we needed a way to be able to still get audio and video analysis somewhere in the chain. And for us, we utilized Tektronix's ABR Sentry platform at our CDN. And some of the things that we're looking for, definitely like Andrew mentioned, the frozen video, so like that black frame still screen is a big use case for us. The QoE scores is definitely huge, so making sure that you have the proper MPEG syntax. Another big one, since we do have multiple providers, we can do stream comparisons. So we can, if we have like high-profile events, we can take a single feed, have different providers do the encoding and packaging for us, let it bake into Tektronix for a week or so, and then we can take that back and say, okay, this one's performing better. Now we're going to go with them for our primary feed. Really great tool for things like that. And obviously, as an MVPD, compliance is a big thing for us. So audio loudness obviously is a big one, as well as closed captions. So a couple times we'll get reports from customer service saying that a channel, they're getting reports that it's missing caption information or it doesn't have closed captions on the channel. It's really easy to just go in and extract a report out of the Sentry, and you can do up to the minute or go over time and see, when it started to have issues. So really good thing for us to have there. So I'm just going to kind of show you some of the actual use cases. So some of those third-party providers on the encoder, we can actually give them a slate to insert if they happen to lose source on the input, which is really helpful for us. So they can either do one of two things. They can either do like a black frame output, or we can do like a custom slate. So if they lose input coming in from their provider, or they have a source issue upstream, on the output they can still keep publishing, which is great because now we can actually notify customers downstream that there is an issue. Tektronix will definitely catch this. This is going to be like a frozen video error, as well as no audio. And then we can take this, we'll get an alert, we can upstream, we can notify folks upstream, as well as let customer service folks know that, hey, this channel is having an outage. Another one is stale manifest that Andrew mentioned before. This obviously is going to cause either buffering or the client to keep playing the same chunks over and over again. For us, it's been great to have the Sentry catch some of these things, because what will happen is if the packager all of a sudden stops publishing content and you're no longer updating the manifest, Tektronix is going to catch that. It's going to see that the media segments are no longer incrementing, and it's going to just drop that video QoE score because it has nothing new to analyze. So again, it's something that's great. We can just get an alert off of that, and then notify people upstream, as well as let our customer service folks know. So this is just a high-level workflow of how we've integrated Tektronix. You'll see on the left here, we've got the multiple providers that are doing the content aggregation, doing the encoding and packaging for HLS, sending it up to an origin server, which is fronted by a CDN. Very, very simple, high-level workflow. And the way we have installed Tektronix, we did it in AWS on EC2 instances, and they are pulling from our CDN. So they're pulling the same manifests and chunks that are going out to our customers. One thing that I don't think Tektronix gets a good enough credit for, they do a really good job of the video QoE and audio QoE, but they actually have a pretty flexible API set. So it allows you to not only just configure and automate and update the sentries through an API command, but you can also extract all of the information that they have via an API. And so what we did is we set up some little kind of like a little microservices architecture, and we have these little workers. One is basically polling all the sentries, getting all of the program statistics across all of our streams, and just constantly grabbing all the information, shoving into a database. And what we can do is we can either create like high-level executive reports on like stream availability and things like that, or we can do a more like engineering level type of view, so we can get a little bit more granular with the data. And for that, in today's workflow, we're actually using a product called Tableau. We have an alerts worker that's constantly checking to see if there's any open alerts from all the sentries. If there are, you'll just shove it right into our dashboard, which is great because we have a bunch of other like third-party or internal written tools that are integrated with our dashboard. So we don't have to like really manage two separate UIs. We can just get all of our information out of our own dashboard there. And then we have an outage worker, which is kind of like anomaly detection. So it's basically looking at all of the current alerts and looking for patterns, looking for changes. And so if it sees it's like 1 or 2 alerts and all of a sudden it gets to 50 or 100 alerts, it will, in this case, it'll notify us via Slack, which is kind of our primary main tool for communication. But we also are integrated with a company called PagerDuty, so it can trigger like an on-call alert. And if it thinks it's a major outage, we can do kind of like an all hands alert. So you don't really have to have that eyes on glass type of thing looking for outages. We can get notified right away. But yeah, it's for us, it's been really great to utilize the API part for Tektronix, as it allows us to integrate with all of our other tools that we use. Let's see. So this is one of those high-level reports that I was talking about. This was using Data Studio. We're pulling all this information out of BigQuery, which is a database, and then we can visualize it with a high-level kind of executive-level graph here, where we can get the availability for all of our streams across 1 day, a week, 30 days, however long we want to go back and view it for. It's also really good to do that stream comparison as well. And then we can do, we can filter out if we just want to see how like all of our local Fox channels are performing and things like that. We can get, kind of just a real nice high-level view. And then, like I said, if you want to get a little bit more granular, this is where you can introduce things like Tableau, which can do kind of up-to-the-minute analysis. So now we can start to identify trends in streams, and really good to start to do encoder comparison and things like that. And it's really, like I said, based off of all of the API information. So they do a pretty good job of all of the QoE and video analysis, as well as being able to provide this flexible API for us to pull out of this information. As far as some of the next steps, one of the next things that Andrew mentioned was the digital ad insertion. That's definitely going to be a big thing for us. We're MVPD. We do a lot of digital ad insertion, and to be able to tie in the SCUDdy35 messages that get marked up into a QOut format in HLS, we're going to be able to take and report off of that, and then tie that into things like our freewheel ad decisioning server, compliance reports. Things like our manifest manipulator, making sure that we're getting the proper ad requests and responses. But that's pretty much it. It's pretty simple. For me, I think that's it. I don't really have too much more. I think we're going to take some questions, but thank you.
So we've got about 5 minutes, I guess, for any questions.
Has there been any examples of
So the question was examples of Sentry being used for VOD assets. Some, to be honest, I would say it's focused much more on live channels. And I think that's sort of its origin, with cable services before moving. Now we've got the ABR version. So, there's things we've got planned with respect to VOD, but I'd say the product is really more designed around live linear streams. For VOD, that's typically where we do more file-based QC, so catch things earlier in the workflow, and test assets that way.
I'm wondering, there's a lot of data guys keep collecting, is deployed on multiple channels. How do you guys handle the database to store those data, to purge?
Okay.
For you guys, you have an internal database, right?
Yeah. So I just want to repeat the question for the video. So we're collecting a lot of data. So how do we manage the database? So, so within the Sentry, the database is set to record up to, I think it's 91 or 92, whatever, like 90 days plus of measurements, and it's sort of the Sentry, whether we sell it as a box or a virtual machine running in the cloud, we sort of size the disk space with that limit of 92 days in mind. Now that the data is in that database.
Yeah, for us, we use BigQuery, so we actually export all of that information and put it into BigQuery, which is cloud-based. So,
And that's from multiple Sentries,
yeah, from
right?
multiple Sentries. We'll take 10 Sentries or however many, extract all the information from all those Sentries, and then plug it into like BigQuery database. Depends on how much you want to pay for it. I mean, you could keep it for as long as you want.
You mentioned you check the DRM keys present on the
Yes.
DRM.
Yeah, so the question was supporting DRM decryption, and yes, we support Play Ready essentially, and so within the manifest will be a pointer to the Play Ready server and so on, and we can follow that. Yeah. Okay, well, we're pretty much right on time. Apparently there's coffee now at 3:30 outside, so thank you all for attending. And as I mentioned, the slides are available on the Streaming Media website, I think, and the video of this session shortly. So thank you.
All right, thank you.